Welcome back to another video. So in this one, we are going to talk about some advanced OOP concepts. We'll talk about special methods or the Dunder methods. We'll talk about inheritance pattern. We'll talk about nested classes. We'll talk about object life cycles. Right. So to get started, let's first create a new Python file. I'll say right click here. It's a Python file. I'll name it as OOP advanced.py. So, what are Dunder methods? What are Dunder methods? Or they are also called as special methods. Okay, Dunder methods or special methods. So, Dunder is nothing but it's a shortcut to double underscore. Okay, so any method starting and ending with double underscore are known as Dunder methods. Okay, they are predefined hooks that allow us to let control how objects of our class behave in various situations. So let's say there are multiple. We'll talk about a few. Let's say there is one method called underscore underscore str underscore underscore. Okay. Then we have underscore underscore add. There is underscore underscore eq underscore underscore. Okay. Then we have underscore underscore len. So this is what this is again will allow us to override the length function. We never call them directly. Okay, they are triggered automatically by Python when needed. Okay, think of them like a secret backdoor to how our class interacts with Python language itself. Okay, so let's take examples on this and we'll talk about these on the go. Our old example, right? Class car, let's say define underscore underscore init underscore underscore, and we'll say self as the first parameter. We'll take brand and we'll take model. Now we'll assign the values to my constructor. Done. Now we'll see what str method will do. So str method will just print, it will return a user friendly string from where it is being called, right? And to implement it, we just have to use the same like how we did the init. We'll say define underscore underscore str underscore underscore self, and we'll say return self dot brand and self dot model. Now we'll see another method which is representation. So we'll say define repr self, and we'll say return self model and brand. And with this I also want to return, I'll say the class name is car. Okay, I'll say car is of model this and brand this. Simple until here. Now to call this, what do we do? We'll say car1 is equals to car of BMW, and we'll say my model is GT. Okay. And now when you print the car, we'll get the output from this str method. Okay. So whatever we are printing from here will be printed when we try to print the car's object. All right. And similarly, when we access the repr, the represent method, what do we get? So let's see, print repr of car1. So represent car1. It will give me the class name, the car, and brand and model name. Let's run this. So what do we get? So the first one gives me BMW GT. The second one gives me car is BMW GT. The init function is my constructor. The init function is my constructor. Then comes the str. Now my str is used to define a meaningful sentence, or say you can have a method here. This is any description that you want to return when the object is printed. And repr is again the same. So it is used to define how an object is represented. So you can have any meaningful messages written here when you are actually developing your framework, or you are on an advanced level of doing something in your Python classes. All right, let's move on to the next one. We had seen str, we'll check about the add. Let's comment this one, and we'll use the same car class, and we'll define the add method inside it. We'll say define underscore underscore add underscore underscore self, and we'll take other as well. Other is the second object that I'm trying to add. All right, so what I'll do here is I'll create two objects. of this class, car class, and I'll try to add those objects and see what happens. So let's see. In my add function, I'll say my new brand is equals to self.brand plus other brand, and I'll say new model. Now let me do one thing here. Model, I'll give it as minus here. All right. So I have defined my add method here. Now I need to create an object of this class, and let's do that. How do we do? We'll say car1 is equals to car. BMW will say X6 is my model, and car2 Ford Mustang. Okay. Now the next thing I want to do is add underscore car is equals to car1 plus car2. Print my add car. What are we expecting? We are expecting that the brand will be added in one single object and it will be separated using a hyphen. Same thing with model. The model will also be concatenated into a single string with plus in between two models. Let's run this. All right. So now what you see here is the default representation of your class, right? I was expecting a brand to be printed here, but it is not. Why? Because we need to have either of the function. So either it's going to be str, or we can also use repr function. Let's add a str method here. So we'll say define underscore underscore str self, and in this I will say print or return my self.brand and self.model. Just have a comma here. Now let's rerun this. Now if you see, the default representation is gone. Now you are just getting whatever you are trying to print from your str method inside your class. So it says BMW Ford and X6 Mustang. So both of the objects are added and is represented in a better meaningful way. Moving on, we will see what is EQ method. Okay, let's comment this. So I'm going to use the same. So I have my car defined here. We'll just define another method. We'll say define underscore underscore EQ underscore underscore, and we'll say self another. Self dot brand is equals to other dot brand. Self dot model is equals to other dot model. That's it. Now again, from here, let's create object of the class, and we'll try to access, or we'll try to compare two objects of the class. Okay, let's say we have car, or let's take this implementation that we did. So we'll take this, we'll say car. We have two car objects. Now we'll just print what is car1 equals car2, and let's run this. It says false because the objects are not the same, the values are not the same. If the brand and the other brand are same and the model is also same, then only it will return me true. So let's create another object saying car3, which is going to be same as car1. All right, I'm going to pass the same parameters. Let's say car3. Now let's print car1 equals car3. If it is the case, then it will return me true here. You see? So EQ is again overriding your double equals operation that we are performing. Okay, so in your class you can override the operators that you are using so that you can perform some custom operations on it. Okay, so this was EQ. So we had seen what an str does, what an add does. We have seen EQ also. The last one we'll take here is len. To highlight something here, we have multiple special methods. I'm just taking these four in my example. You can always refer to the documentation to learn more on what methods are available in Python. Let's have the same set of example. I'll copy it and I'll do some changes here. I'll comment this class. I'll create class, same brand and model I have. Now instead of EQ, I'm not going to use this. I'm just defining a new underscore underscore. I'll say length, and I'll say return, say length of self dot brand plus length of self dot model. I'm just going to use one object here, car1, and here also I'm just going to say length of car1. Let's run this. So it says 5. 5. Why? Because 3 is BMW and x6 is 2. So combining these two, it returns 5 as the length. So this is how you can customize what a length method is going to do in your class. So suppose you are writing a test suite class to manage multiple test cases. Okay. So if you have the implementation of underscore underscore length method inside it, so then calling length of the suite will return the number of test cases that is inside the suite. Just like how you get length of a list that gives the number of item inside that list. Similarly, length of the particular class will return you the number of objects or the number of test cases that you have created for that class. All right. So moving on. So where can these be useful from the perspective of Selenium and framework creation? Right. So in Selenium automation, imagine you are building a test page element and adding str there helps the logs to be more readable, like submit button on login page instead of just giving an object reference of that class or the memory reference of that class. Okay. With EQ, you can compare two elements in assertion. We'll say assert element 1 is equals to element 2. With add, you can merge two different test cases result object and that you are going to use your in your daily reporting. So while you are implementing length, we just discussed, you can use it in your test suite where you can get the number of test cases you have created. And REPR, the represent or the represent method, is very useful when you are debugging because your message that you are printing makes it more readable rather than just some technical messages that you are going to print in your logs. These concepts you are not going to use directly while you are scripting, but this is very much useful when you are trying to develop your framework or you are trying to enhance your framework. So we are going to use these objects when the complexity is growing and we want to simplify how they interact with each other and Python in itself. All right. So moving on to our next topic today. The next one that we have is inheritance. Let's see what inheritance is. So inheritance in Python allows one class to inherit properties and behavior from another. It promotes code reusability, organizing your code in a better way, and extending your code or extensibility of your code inside your Python classes. These are useful when we are developing an automation framework with some modularity in it and with the scope of extending it in the future. Okay. So if we say inheritance, so there are three patterns in inheritance. Okay. So one is your multi-level, second is hierarchical, and third one is multiple. So my multi-level inheritance is where a class inherits from a class which itself inherited from another. We had seen inheritance in our earlier videos as well. So this is not going to be the basic one that we were seeing here. We are going to talk a, a step ahead of it. So a multi-level is where my base class is inherited from a class which is already inherited from another class. So there are multiple level of inheritance, right? What is hierarchical? Hierarchical is where your child classes inherit from single parents, but there are multiple child classes. So there are more than one child class which is implementing your parent class. And then we have multiple inheritance. Multiple inheritance is nothing but a child can have multiple parents or it can be inherited from multiple parents. So moving on, let's see examples on what these are. Let's comment this one and we'll say here I'll add a comment here as well. I'll say we are talking about inheritance here. Okay. So again, let's see how multi-level inheritance works. So how this works is we'll have a class called car and we will have a parent class called class vehicle. And I'm just going to add a basic method inside it. I'll say define start, take self. I'll just say print starting. Okay. Same thing I'll do with car also. I'll say class car. It is going to inherit from vehicle, and we'll say define drive self, and I'm going to print a message driving a car. Another class we'll say electric car, which inherits from car class, and we'll say define charge self, and we'll print charging electric car. Now from here, let's create the object of the class. My Tesla is equals to electric car, and I'll say Tesla dot start, I'll say Tesla dot drive, I'll say Tesla dot charge. All right. So I don't need objects of each of these classes to call their methods. Instead, I can just use it from my Tesla object because it is inheriting from car, and car in itself is inheriting from vehicle. So all these methods are accessible to my electric car class. Okay, let's run this. So it says starting, which is from vehicle class, driving a car, which is from car class, and then we have electric car. I'm getting charging electric car. All right. So this is how a typical multi-level inheritance looks like. Now the next one that we are going to see is the hierarchical. So let's take another example here. We'll say, let's first comment this one. My class car, and in this car I'll say define engine self parameter, standard engine. All right, and we'll have class petrol car, which inherits car class, and we'll say in this I don't want an engine, let's say I define fuel type, and we'll say print petrol. That's it. Another class will have diesel car, I'll say diesel car self. I'll have the same method, fuel type, we'll say here print diesel. Now let's create the objects. Honda has a petrol car, and in this petrol car I'll say Honda dot engine, and I'll say Honda dot fuel type. Right, again I have a different car as Ford is equals to, it has a diesel car, and we'll say Ford dot engine, and we'll say Ford dot fuel type. Okay, so both petrol car and diesel car share the same parent class, which is car. They inherit the engine but define their own fuel type. Okay, so let's run this. What do we get? We have a standard engine with petrol type, and we have a standard engine with diesel type. So this is how hierarchical inheritance works, or you can implement hierarchical inheritance. So on your framework side, this is like having different page classes inherit from common base class with wait for element or click button method, right? So you have defined all your wait for element properties or click button properties inside your base class, and you are using the same thing throughout all the classes or all the pages where you are navigating to, right? So you have set some wait time in your the default wait time, or some certain parameters like say your request response should not take more than 10 seconds. So you have defined that in your base class, and in every request you are just calling your base class, or you are inheriting that property from your base class to your class. You are not rewriting those properties again and again, right? Now let's take an example on how multi-level inheritance works. Let's comment this one. Let's say we have a class called GPS. Okay, and GPS will have a function or a method called locate me, or just say locate, we'll say self, and we'll say print GPS is located, or GPS is locating the location. Now we'll have another class called infotainment system. We'll say define play underscore music, and we'll just take self here, print play music. All right, we'll just have this my child class. I how I'm going to implement, I want my cars to have both of these properties. Yeah, I want my car to have GPS, I want my car to have infotainment system as well. So it should inherit from these both of these classes. So to do that, we'll say, so we have a car class called car, and this car has GPS, and it also has infotainment system. And we'll say inside this, we'll say define auto drive. Right, we'll say print auto drive is enabled. Now calling is simple. We'll say my car is Kia, and Kia dot locate, say Kia dot play music, and Kia dot auto drive. So using one child class, you are going to inherit properties from multiple parent classes. Let's run this example. What do we get? So you should be able to see all the three messages here. So GPS is locating the location. We have play music. You have auto drive is enabled. One last topic inside inheritance I want to talk about is where you are going to use the word super. Okay, let's say we have a class vehicle, right, which is my parent class, and a class car implements the vehicle. Electric car again inherits from car class. Let's say I have a Tesla again. Tesla is my what electric car, and we'll say Tesla dot start. Now let's run this. What do we get? We got all the three messages printed here, right? But why? It's because of this super keyword. We had seen this earlier, right? So let's comment the super keyword and see what happens. So I'm going to just run this without the super keyword. So it just says electric car initializing battery, which is coming from my child class. So by default, this start method is called. Now from here, when I say super.start, it will go to its parent class and look for the the start function, and it will try to run that. So if I run this, it will print the other message as well from car class. Now from here, if I again do a super, it will again go to my vehicle class, and it will start look for that function or the method, and it will execute it, right? So if I run, I get this output. Right? So this was just a brush up on super, because we had already seen this earlier, but I just wanted you to keep a note of it, because this will be very much useful all the time when you are dealing with inheritance. In terms of inheritance, we had seen multi-level, and we had seen multi-level, we had seen multiple, and we had seen hierarchical. Now, to summarize what we had seen in inheritance, a multi-level lets you stack the classes in hierarchy. A hierarchical lets many classes share single base. A multiple inheritance allows combining behavior carefully. Okay, and you used super to access parent class logic. And then next in the chain, we are going to talk about nested classes or inner classes. So in Python, you can define a class inside another class. This is known as inner or nested class. Think of it as organizing related logic together. The outer class is the main structure, and the inner class acts like a helper or component class that belongs to the outer one. Okay. So this is helpful for encapsulation. This is helpful for grouping functionalities together. This also promotes avoiding to avoid namespace pollution. But this is not same as inheritance. It's all about logical containment. So to talk more on this, let's take examples on how we can implement it, and then we'll discuss it on the go. We'll say nested class. Again, let's stick to our old example, the car, and we'll first define a class car. Self dot brand is equals to brand. Don't want this as well. Here I'm going to say I'll have another method called define. It's a show self print self dot brand. Now inside this class, I'm going to create another class called engine. I'll say class engine, and where I'm going to say define my engine specs. Fine engine specs, and I'll say print this is a V8 powered engine. All right. Now, if you see, I have a class here. Now, in our normal approach, what we'll do? Car1 is equals to car, and the car is of BMW, and we'll say car dot show. Now, if we run this, we are not going to touch our engine class. It's just going to print BMW. This class engine is not accessible to outside the car class, but inside the car class also you have to use it. So you have to call this engine, or you have to initialize this, right? So how do we do it? So to access anything inside this engine class, we'll first have it in our init. Now we'll add it as a attribute here. We'll say self dot engine is equals to self dot engine. Now this time I am assigning the class engine to my engine method here, or engine attribute. So if you see, I have self dot engine. This engine is nothing but my class. And similarly in my show, I'm going to go here and I'll say self dot engine dot show. What is that? Engine specs. Yeah. So what did I do here? I assigned the class to a variable or to an attribute here. Now I use this attribute to manage my, or to access my method that was inside the inner class. Let's run this now. What do I get? Module not found, no module name Django. Oh, this was some import that accidentally happened. Let's rerun this. So you see, you get BMW, and then this is a V8 powered engine. Now, if you see here, the car is the outer class. Inside it, there is a nested engine class that is not meant to be used outside the class car. Okay, and self dot engine is equals to self engine creates an instance of the inner class when a car is created. So when I'm trying to create an object here, so my constructor is hit. In this constructor, object of my inner class is also created, and car.show will call the self.engine function here. I mean, engine.specs function. Now, where are you going to use this in comparison with your Selenium? So let's say you have a class, and this class name is login page. Now inside this login page, you have another class which is locator. Alright, in this locator, you will store all your variables, username, password, alright, and you will assign the XPath location here. Okay, you have assigned the XPath location to it. Now, from here, when you are trying to define a login method, so inside your login page, you are going to have a define login, right? So you'll say driver dot find element, and in here you are going to say self dot locator, which is your class, dot whatever variable you want to pass, say username. Okay, so what happens here is all of your locator are inside your main parent class here. Okay, and this cannot be used, the inner class cannot be used outside your login page, right? So you don't have two different page to keep your objects. You are just keeping your object in an inner class which is being used while you are on the login page. As soon as you are out of your login page, the object is no longer in use. So to summarize, we use inner or nested classes to logically group helper functionalities that only make sense inside an outer class. So remember, keep inner class for things that aren't reusable anywhere else. So the next time when you are trying to keep these objects, the locators inside your class, just do a thorough analysis. Is there a better way to keep these objects outside the class, or you just wanted to have it inside your class? Okay. So the next one that we are going to talk about here is the object lifecycle. Okay. So there are two keywords that we are going to refer here when we talk about object classes. That is, one would be your init and other one will be delete. So let's see what these are. So one is underscore underscore init, other is underscore underscore delete. We had seen init all the time while we were dealing with classes, right? But we haven't seen delete, and there is a reason to it. Your init is the constructor and delete is the destructor. So init is by default called when a object instance is created, or when an object is created, and similarly delete destructor is automatically executed when the object is about to be destroyed. So in the background, Python uses reference counting to track how many variable references the object, and it automatically frees the memory when there are no references left. So that's the reason we haven't called delete ever, because Python decides it when it wants to run that. Now let's take a simple example on how this is done and we'll close for today. Let's take an example here. Let's comment this one car class, class car, and in this one I want to first have car. I'll say define init. I don't want all of these variable. I'll just say brand, and I'll say self dot brand is brand. I'll again print, and similarly I'll have a define underscore underscore delete. All right, and we'll say the brand name deleted. So while creating object, we'll say print creating a car, and we'll say car Ford. We'll say print destroying the car, and we'll say car. We'll say delete car. Okay. So if you see here, the first one says creating a car, which is from my outside my class, and then it says the brand name is Ford, where I'm creating an object of the class, and the default constructor is triggered. Now destroying the car, and I pass the keyword delete car, so my method is printed, the brand name Ford is deleted. Now these things will be useful where we want to write a step down or step up constructor, right? Like say you have in your Selenium we have a WebDriver manager class, all right, where in my init I'll start creating browser sessions, and then I'll perform my test. In my delete, I'll just have everything to clear the memory, and I'll just pass a custom message that saying the browser session that I created is closed now. But both of these functions would be called by default when I call or when I execute my Python code. So if you want to see that, so let's say we don't have this. Let's say we don't call this keyword, but I'll still have this custom message here, right? So let's run this. So if you see, the brand name Ford is deleted. We haven't called it, but Python is explicitly doing it when the reference count is 0 for that particular variable. To summarize this, init helps to initialize your object and is great for setup logic like opening browser, connecting to database in context to your Selenium. Whereas delete is the cleanup method when Python determines it a function or a object is no longer needed, it is automatically executed. Python uses your reference counting and garbage collection behind the scene. You don't have to use it explicitly, right? You can define it, or you can have some custom messages or text inside it, but you don't have to call it explicitly. So whenever you are designing your classes, make sure you have the lifecycle awareness. It makes your code more robust, especially in longer suits or in frameworks. So that's all I wanted to cover in this one, and as well as in the OOP concept. Now, so in the next one or two videos, I'll try to wrap up any pending topics that I have or I have missed inside the Python basic, and then we'll switch to Selenium, right? So drop a like if you have watched the video, and I'll see you in the next one. Thanks for joining, guys.